Welcome to the deep dive. We are at, well, just a fascinating, almost dizzying moment in artificial intelligence research.
It really feels like an inflection point, doesn't it?
Absolutely. We're talking about a transformation that's redefining not just tech, but, the very essence of scientific discovery itself.
Hmm.
Imagine systems that aren't merely tools, but genuine scientific collaborators.
Right, partners. Fundamentally altering how breakthroughs actually happen.
It's a huge
It
shift.
is. And that's why today we're sort of pulling back the curtain on the AI research community.
Okay.
Our mission really is to explore its demographic makeup, how people get into this field, the different pathways.
And crucially, where the real research power is, well, consolidating.
Exactly. Where that power lies.
Our goal here is to uncover how these underlying patterns are influencing AI development.
And what that means, ultimately, for the future of human AI collaboration. It's a big question.
It is. And to do this, we've gathered, well, quite a comprehensive stack of sources.
Indeed. Yeah, our analysis draws from demographic data from the big AI conferences, NeuroPS, ICML, ICLR,
The
AAI,
usual suspects.
right.
Mhm.
Plus institutional reports from leading research orgs, government stats like NSF data, and peer-reviewed studies from, say, 2020 to 2025.
Okay.
And we've also folded in insights from places like Pew Research, Element AI's analysis of, I think it was 4,000 researchers, and of course the Stanford AI Index report. Can't miss that one.
Essential reading. So, why does this particular deep dive matter to you, the listener? Well, consider this.
Hmm.
Research consistently shows diverse teams produced, well, higher quality
That's a
outcomes.
well-established finding across many fields.
Right. And in AI, for example, female contributors have been shown to consistently produce superior code quality.
Despite being a really small percentage of the workforce.
Exactly. Which should, give us pause right there.
It's a crucial insight. Because on the flip side, this concentration of AI research power, in just a handful of institutions and individuals,
Yeah.
it could inadvertently create bottlenecks. It could limit the scope of research, uh, how resources get allocated.
So if only a few voices are really shaping this tech, what problems are we not addressing? Whose perspectives are maybe getting missed?
That's the key question. As these AI systems get more and more capable, understanding who's building them, how the teams are structured,
Mm-hmm.
that dictates who gets access, right? And ultimately, what discoveries even get made. It's really about shaping the future of discovery itself.
Couldn't agree more. So, to really get our arms around this, we'll be looking at 5 key dimensions, sort of peeling back the layers of the AI research world.
Okay, what are they?
So, first, demographics. We'll look at those imbalances: gender, nationality, age.
Got it.
Then, the educational pathways. How are people getting into AI now? It's changing.
Right.
Third, that concentration of power and resources. It's pretty unprecedented.
We'll dig into that.
Fourth, international collaboration and talent mobility. Those complex patterns of cooperation and, well, competition.
And finally, maybe the most significant transformation of all, how human AI collaboration itself is evolving.
Okay, that sounds like a great roadmap.
Mm.
So to really understand this landscape, maybe the first place to start is the people. Who is actually doing this research?
Mhm.
And the numbers here, especially around gender, they're pretty stark.
They truly are. Globally, only about 18% of AI researchers are women. Just 18%.
Wow.
And if you zoom in on industry, it's even more pronounced. You look at the big tech companies. Google's around 11.3% female representation in AI publications.
Just over 11%.
Microsoft, about 11.95%.
Well,
IBM leads among those, but still only 15.66%.
still quite low.
Yeah, it's a persistent underrepresentation. It's a really significant finding we need to grapple with.
So if we accept the premise that diverse teams lead to better outcomes, better code quality, as the data suggests,
Yeah.
what are the implications of having such a, well, narrow demographic shaping these foundational AI
Oh,
systems?
that's the core issue, isn't it?
Could it limit our collective intelligence or the utility of the AI being built?
It absolutely could. A lack of diverse perspectives can lead straight to biases.
Mm.
Biases in data, in the algorithms, in the applications,
Which can then perpetuate existing inequalities.
or even create new ones. So it's not just about fairness, though that's critical. It's about the actual quality and usefulness of the AI systems we're creating for, a very diverse world.
It's fascinating how that plays out geographically, too. Nationality, distribution.
Oh, absolutely. The U.S. is still a major hub, hosting about 27% of advanced career AI scientists globally.
Okay.
But here's a twist. Foreign national participation in top-tier U.S. research, it's actually declined. It was 55% in 2019, down to 42% in 2022.
Huh. That is interesting. What's driving that?
Well, it suggests a shift. Meanwhile, China has really emerged as a major player and is doing a much better job retaining its own domestic talent.
Ah, so they're not necessarily going abroad as much?
Exactly. That's a noticeable change from previous trends where many top Chinese researchers would seek opportunities in the US or Europe.
So it's not just about U.S. dominance, but the flow of that talent is changing. Is it like a global tug of war for the best minds?
That's part of it.
Or is it that AI ecosystems elsewhere are just maturing,
I think it's likely a bit of both. Countries like China, India too, they've invested significantly in their own AI capabilities, their infrastructure.
creating compelling reasons to stay?
Exactly. Creating opportunities that encourage talent to stay home and build. It points towards a more, maybe, multipolar world of AI innovation starting to emerge.
Interesting. And what about age? I sort of picture AI labs full of very young people, but the data paints a different picture.
It absolutely does. It might surprise you, but a significant chunk, 61% of AI specialists are actually 40 years old or older.
To see 1%.
Yeah, the average age is over 40, which reflects how the field has exploded from this niche academic thing to a mainstream powerhouse.
So lots of people transitioning in.
Exactly. Many leaders came from adjacent fields, physics, math, rather than starting purely in AI from day one.
But there's a generational thing with tools, right?
Oh, definitely. There's a clear divide in AI tool adoption. You see Gen Z researchers, 48% show high adoption rates.
Nearly half.
Compare that to baby boomers, only 22%. So, yeah, maybe a comfort level difference or different approaches to using the latest AI tools.
That makes sense. It could highlight a sort of knowledge transfer challenge or just different ways of working. And speaking of shifts, let's talk about brain drain.
Mm-hmm.
We're seeing this major flow of talent from academia to industry.
Yeah, this brain drain, or maybe brain circulation is a kind of term,
Yeah.
huge trend. And it's critical because it fundamentally reshapes educational pathways and the kind of research that gets prioritized.
How so?
Well, industry offers just vastly superior access to computational resources, right? Massive data sets. And let's be honest, significantly higher compensation,
We're talking how much higher?
like 2 to 3 times higher salaries easily, which makes it incredibly tough for universities to compete for that top-tier research talent.
And that impacts where the real cutting edge stuff happens.
Precisely. It shifts where frontier research is likely to be conducted.
So, if the workforce is shifting and the incentives are pulling people towards industry, how are people actually getting into AI now? Which brings us neatly to those evolving educational pathways.
Mhm.
It's not just computer science anymore, is it?
That's right. I mean, CS still dominates at the undergrad level. You see it in, what, 75% of job postings?
Still the main route.
But it's far from the only route. Math and statistics are huge. They show up in 65% of roles. Makes sense, given the theoretical underpinnings.
And physics, I've heard that's common too.
Yeah, physics provides that strong analytical foundation. And various engineering fields are critical, too, for that hardware-software understanding.
What I find really interesting is the interdisciplinary growth. It feels like the field needs more than just coders now.
Oh, absolutely. It's maturing. You see neuroscience and cognitive science bringing insights for brain-inspired AI for understanding intelligence itself.
Psychology too.
Crucial for human-AI interaction. Linguistics is obviously essential for NLP. And even philosophy is gaining ground for AI ethics, reasoning systems.
So it's broadening out.
Totally. Reflecting how AI is touching, well, pretty much every aspect of human life and society.
And once people are in the field, what about graduate education? Is a master's enough, or do you really need that PhD for the top jobs?
It depends on the role, really. A master's degree often leads to more applied positions in industry, implementing, optimizing existing solutions. Average salaries there are around $137,000.
Still pretty good.
Not bad at all. But for those senior research positions, ones pushing the boundaries, PhDs are still pretty essential.
And the pay reflects that.
Yeah, average salaries jump to around $204,655 at the big companies like Google. It shows the deep research background, the theoretical grounding, is still highly valued for innovation.
What about postdocs? Are they still a common step?
Interestingly, traditional academic postdocs seem to be declining a bit as a pathway into industry. But we are seeing specialized industry postdocs emerging.
Ah, like a hybrid model.
Exactly, blending academic rigor with commercial application right inside the company labs. It's a new kind of pathway.
Okay, so given these shifts in talent, these evolving pathways, it leads us right to the next big question. Where is the actual power, the resources consolidating?
Hmm.
This concentration seems, well, truly unprecedented.
It is astonishing, frankly. In industry, you have giants like Google and DeepMind just dominating publications. DeepMind averages something like 47 citations per author.
That's huge impact.
Massive impact. OpenAI, maybe fewer papers overall, but exceptional impact, 96 to 125 citations per author on average.
Wow.
And Microsoft is right up there with Google, partly boosted, of course, by its huge $10 billion investment in OpenAI.
And this kind of industry dominance must put academic institutions at a fundamental disadvantage.
Significantly so.
Yeah.
Think about Stanford AI Lab, a world-renowned academic center.
Right.
They have maybe around 300 GPUs, roughly. Now compare that to Microsoft.
Yeah.
They report having access to 1.8 million GPUs.
1.8 million. That's not even the same league.
It's not just a resource gap, it's a different universe. It fundamentally redefines where the truly foundational resource-intensive breakthroughs are likely to happen,
Shifting the center of gravity from open academic inquiry.
towards proprietary corporate R&D. It's a massive challenge for universities trying to stay at the absolute frontier.
So where are these superpowered research hubs located geographically? Is it really clustered in just a few superstar cities?
Overwhelmingly, yes. The U.S. commands something like 62% of global AI investment. That's $471 billion out of $750 billion since 2013.
Huge numbers.
And within the U.S., incredibly concentrated. San Francisco Bay Area alone captures over half of the total U.S. AI investment. Yeah, creating these superstar cities. The Bay Area saw $20 billion in investment just in 2023. Then you have Seattle, New York, Boston as other major hubs.
And training those big frontier models costs?
Tens of millions of dollars, minimum, which creates just an incredibly high barrier to entry for smaller companies, startups, even most universities.
So for a small startup or even a decently funded university lab trying to compete on that scale, it feels almost impossible.
It's extremely difficult to compete at the absolute cutting edge of large model training without that kind of backing.
Does this concentration then affect international collaboration, talent mobility? That's our next layer here.
It's a really complex picture, cooperation mixed with competition. The U.S. shows about 37% international collaboration in its AI papers.
Okay.
But interestingly, the U.K. actually leads here with 61% international collaboration. China's rate is lower, around 17%.
So varying approaches.
Very much so.
Yeah.
But the general trend, despite geopolitical tensions, has actually been towards increasing international cooperation. Countries like Japan, the U.S., Germany, UK, they all increased collaboration rates between 2003 and 2022.
So the science itself kind of forces collaboration.
It suggests the sheer technical difficulty, the scale of the problems, is still pushing researchers globally to work together, even while nations compete.
Okay, so even with national competition, the science pulls people together. What about where researchers actually choose to live and work? Is that global talent mobility shifting?
Yeah, those patterns are definitely evolving. We mentioned earlier that 42% of top-tier AI researchers in 2022 were foreign nationals working abroad.
Right, down from 55%.
Exactly, which points towards increasing talent retention in home countries. China, as we said, has really expanded its domestic talent pool. More researchers are choosing to stay put.
Yeah, and India, too.
India is showing growing retention as well. It was near 0% back in 2019, but now around 20% of top Indian AI researchers are staying domestically.
That's a really significant shift over just a few years.
It is. It implies maybe a more distributed global landscape for AI talent emerging over time, which could actually be quite healthy for innovation overall.
Okay. Now, for our final layer, and maybe the most transformative one, the evolution of human-AI collaboration. This idea that AI systems are moving beyond just being tools.
To becoming true collaborative partners. Yeah, this really feels like the inflection point right now.
How has that changed? What did the early stages look like?
Well, early on, stages 1 and 2 maybe, researchers mostly used AI for automation. Automating repetitive tasks, data processing.
Standard stuff.
Standard stuff. But we've moved way beyond that. Now, in stages 3 and 4, AI is functioning more like a creative partner.
How so? Give me an example.
Researchers are asking AI to, say, outline the pros and cons of a research direction, or surface relevant case studies from vast literature, or even help identify potential unintended consequences of an approach.
That's a much deeper level of interaction.
It is. And what's really fascinating is the data shows strategic collaborators, people who really integrate AI effectively into their workflow, are seen as 1.8 times more likely to be innovative teammates.
Wow, 1.8 times, so it's not just about individual productivity.
It seems to boost perceived team innovation too, and the productivity boost itself is far from just incremental.
What kind of numbers are we talking about?
Get this. AI-assisted scientists have been shown to discover 44% more novel materials.
44%. Think about that for drug discovery, sustainable energy.
Exactly. It translates into 39% more patent filings and a 17% increase in product innovation metrics. It's substantial.
So it's this combination, AI handling the massive data, pattern recognition.
While humans provide the causal interpretation, the strategic direction, the context, it's a remarkably powerful pairing.
It changes the role of the scientist.
Absolutely. From maybe the lone genius model to more of an orchestrator, a conductor of intelligence systems.
This must be leading to entirely new ways of doing research, new paradigms.
For sure. AI is enabling things like automated experimentation,
Meaning,
where AI can help design experiments, even control lab equipment, using real-time data to refine parameters on the fly.
wow.
It enhances pattern recognition in huge data sets with way more precision than humans can manage. And it can generate hypotheses that might seem totally counterintuitive to us.
Pushing beyond human biases or blind spots.
Precisely. Think about Google DeepMind's work discovering new materials that's accelerating material science.
Or alpha geometry.
Right. Achieving Olympic-level performance in geometry proofs. That shows AI tackling complex theoretical challenges. And IBM has GT4SD for accelerating hypothesis generation across different scientific fields.
So with all this incredible power and capability, which seems, as we discussed, so concentrated, does that mean it's only going to be accessible to those few big players? Or is there a counter-narrative? Is there a democratization potential here?
There absolutely is a democratization potential.
Huh.
And it's a really vital counter-narrative to that concentration story.
How is that happening?
Well, open source frameworks, first and foremost,
Yeah.
TensorFlow, PyTorch, they've put powerful deep learning tools into the hands of countless developers worldwide.
Lowering the barrier to entry significantly.
Hugely. Then you have community-driven models. Look at Bloom, created by over 1,000 researchers from more than 70 countries,
A global collaboration.
showing that open collaborative development can rival proprietary systems. Plus, cloud computing, pay-as-you-go models reduce infrastructure costs. And even no-code platforms are emerging.
Allowing non-technical people to build AI.
Exactly. So while concentration is real and powerful, these democratizing forces are also pushing back, opening things up.
Okay, let's try and pull this all together. Let's recap what we've unpacked today.
All right?
You've seen AI research is at this really critical juncture, defined by, first, significant demographic imbalances, particularly gender.
Which, as we noted, directly impacts quality and applicability. Only 18% women globally.
Right. Then, this extreme geographic and institutional concentration of resources.
Hugely skewed towards a few industry players in specific cities, mainly in the U.S., which holds 62% of global investment.
With power shifting dramatically from academia to industry, driving that brain drain or shift.
Over 50% of AI PhDs heading to industry now.
And all this is happening while we're seeing this truly transformative evolution in human-AI collaboration.
Where AI moves from just being a tool to a genuine partner in discovery.
These factors aren't just shaping today's research, are they?
No, they are fundamentally setting the entire future trajectory of AI. That concentration, that demographic homogeneity, it creates real concerns about limiting innovation, about missing needs from diverse global populations.
And the shift to industry changes the priorities, the very organization of research.
It really does.
So this deep dive, it really surfaces a fundamental question for all of us, doesn't it? Is the current path of AI research, with this homogeneity, this resource concentration, this clustering, is it actually compatible with broad democratic participation? Especially for technologies that are going to profoundly shape all of human society.
That's the crux of it. As these systems become more powerful, more influential, ensuring broader participation in how they're developed isn't just about better science.
It's about governance.
It's about democratic governance, about social equity, how the research community and society as a whole responds to these patterns we've talked about. That will determine if AI development truly serves broad human interests, or if it mainly ends up amplifying the advantages and inequalities we already have.
A really crucial question to end on. What stands out most to weigh you from everything we've unpacked today?